This topic is current, voltage, and resistance. When there is an electric potential difference in between 2 points in a conductor, the electrical charge will flow from higher potential point to lower potential point. The flow of electrical charge makes up the electrical current on the conductor. The conclusion is, electric potential difference make up the current in conductor. The phenomena of electric charges flow from one point to another point due to the potential difference that has applied to the 2 point. Can be understood through the concept of electric current, voltage, and resistance. The current, voltage, and resistance are the three importance parameters to describe the phenomena of moving charges in the conductor. The concepts of voltage, current, and resistance are difficult to understand because we cannot see them. To have a better understand the concept, we may use an analogy. When describing voltage, current, and resistance, a common analogy is a water tank. The condition of water and water flow from the tank is the phenomena that can be seen. In this analogy, the analogy of charge is water amount in the water tank. The analogy of voltage is the water pressure. The analogy of current is the water flow. The analogy of resistance is the hose width of the water tank. We may try to answer this question for our understanding about the concept. Why there is a water flow from the water tank? Because water is reserved at higher position in water tank, this causes the water pressure. Water pressure is the physical quantity that cause the water flow. Same to the current in a circuit. Why there is an electric current in a circuit? Because charges are accumulated in the electric source, and this causes the potential difference. What happens if more water is added into the water tank? The answer is, the water pressure increase, and water flow will be faster. What happens if the more charges is added in the power source of circuit? The potential difference increase, and current will be increase. This topic, we will go to the detail of voltage. Voltage is the electric potential difference between 2 points in a conductor or circuit. For example, the 2 points are the point 1 and point 2 in the circuit, and the potential difference between the 2 points, point 1 and point 2, can be gained by minus the potential in point 1 with the potential in point 2. This is minus V1 with V2. The positive terminal, which represented by a longer bar, will have higher potential than the negative terminal, which represented by shorter bar. In our daily life, for example, when the 2A battery is said to have 1.5 V, this 1.5 V is actually gained by minus the potential in positive terminal, with potential in negative terminal. The analogy of voltage is the water pressure in a water tank. The net pressure in the water system is the pressure in tank A, minus with pressure in tank B. The water pressure in a water tank can be increased by adding more water to the water tank, or installing a water pump. For example, when add more water in tank A, will increase the net pressure in the water system. The voltage in a circuit can be increased by increasing the positive charges in the terminal positive. The voltage in between the conductor can be measured using the voltmeter that connected in parallel to the conductor. Here is a question: what happens if the voltmeter connected in series to the conductor? If the voltmeter connected in series to the conductor, the voltmeter reading becomes 0. Because, if the voltmeter connected in series to the conductor, the voltmeter is about measure the potential different in single point instead of 2 points. And, since voltmeter is with very high resistance, current will drop to 0 in the circuit. The SI unit for voltage is volt, and character big caps V is used to represent the unit. This topic, we talk about electric current. When an electric potential difference is applied between 2 points in a circuit, the electric charges flow from higher potential point to the lower potential point. For example, point 1 and point 2 in the circuit, at which point 1 has at higher potential and point 2 has lower potential. The higher potential point is represented by a longer bar. The lower potential point is represented by a shorter bar. Potential difference is equal to the potential in point 1 minus with the potential in point 2. The electric charges flow from point 1 to point 2. If V1 is equal to V2, it means V is equal to 0, and there are no potential difference, and no electric current occur. Analogy to this electric current is when there is a net pressure difference in the water system between tank A and tank B. The water flow from a higher pressure to a lower pressure tank, from tank A to tank B. When the water pressure in tank A and tank B are unequal, the pressure difference in the water system is equal to 0, and no water flow will occur. The conclusion is, electric current in a circuit is due to potential difference, and the water flow in a water system is due to the water pressure. Electric current is the rate of electric charges pass through a point. The rate of electrical charges pass through a point is referring to the amount of charges that move through a point within 1 second. If the charges are not in moving, it means there are no current is flowing in the circuit. Electric current flows from the higher potential point to the lower potential point, at which positive terminal is at high potential point, and the negative terminal is at lower potential point. The electrons flow from lower potential point to the higher potential point in the circuit. The flow direction of electrons is always in opposite direction of the current. The flow of electric current can be measured using the ammeter that connected in series in the circuit. What happens if the ammeter connected in parallel to the circuit? The internal resistance of ammeter is very small. The current of the circuit will choose to flow in the ammeter loop, and no current will flow in the main circuit loop. Such a phenomena, because current will choose to flow more in the path with small resistance. High current in the ammeter will cause the ammeter damage. The SI unit for current is ampere, and character big caps A is used to indicate the ampere. Now, we talk about resistance. Resistance is the ability of a material to resist the flow of electric current through it. When a voltage is applied to a circuit, the current will flow in between the terminal of the circuit, and when resistance of the circuit is higher, the flow of the current will become the smaller. Such a phenomena because resistance will cause the charge move slower, or lesser charges will move through it. The analogy of the resistance is the water hose width in the water system. When the water hose width becomes smaller, water will flow in slower speed. Same amount of water will take a longer time to flow from tank A to tank B. The resistance of a material depends on 4 factors. The first factor is the type of material that used to conduct electricity. From periodic table, we know that the matter in the earth can be categorized as metals, metalloids, and non-metals. Metals have very low resistance. Metalloids have higher resistance compared to metals. Non-metals have very high resistance. In among the metals, silver has the lowest resistance. The second factor that affect the resistance is the length of the material. When the length of the material increase, the charges require more energy to complete the path. So, the longer the material, the higher is the resistance. The third factor, the cross-section area of the material. We may take a copper cable, as an example. If the cross-section area of the copper increase, more charges can pass through the cable in once. Hence, it has lower resistance. If the cross-section area of the copper decrease, less charges can pass through the cable in once. Hence, it has higher resistance. The fourth factor is temperature. In higher temperature, the atoms gain higher kinetic energy, and vibrating. More collision occur between the free charges and the captive charges. Each collision uses up some energy from the free charges, and it is the basic cause of resistance increase. In low temperature, less collision occur between the free charges and the captive charges. So, the charge is able to move faster. Hence the resistance is lower. All materials are with electric resistance. For electricity conduction purpose, resistance is unwanted, because resistance will cause energy loss. The resistor is made to have a certain resistance, and used in a circuit to control the current flow in the circuit. When a lower current is required in the circuit, the resistor with higher resistance will be installed. There are two kinds of resistor. The first is resistor with a fixed resistance. Resistor with a fixed resistance has two terminals. The second kind of resistor is rheostat with adjustable resistance. Rheostat has three terminals. For its function to be adjustable, the center terminal will need to always connected to the lower potential point. In the above circuit, the net resistance is always equal to R1. When adjust the arrow to the upper side of the resistor, the net resistance will reduce. When adjust the arrow to the lower side of the resistor, the net resistance will increase. The S.I unit for electric resistance is ohm, with symbol omega. Resistance of a material can be measured using the resistance meter, and only can be measured when the material is not installed into the circuit. Because, if the resistance of a resistor being measured at a installed circuit, the resistance from the wire, internal resistance from the voltage source, will influence the reading, an inaccurate reading will be displayed. This new topic, we will talk about the relationship between current, voltage, and resistance. Their relationship is described by Ohm's law. The relation between current, voltage, and resistance can be described by Ohm's law. Ohm's law stated that the current that flows through a conductor is directly proportional to the voltage that across the terminal of the conductor, with the condition that the temperature and the other's physical condition are constant. For example, the conductor here is the resistor with resistance R. The keywords about the Ohm's law are current, voltage, and directly proportional. Directly proportional is meant that the current I that flow through the conductor will increase when the voltage VR across the conductor R increase. For example, when VR change from 0 V to 1 V, the current will change from 0 ampere to 1 ampere. When VR change to 2 volt, the current I will change to 2 ampere. In the above circuit, since the supply voltage VE is connected parallel to the resistor, the supply voltage VE will always equal to the voltage across the resistor. With this, we can said that when supply voltage increase, the voltage across the resistance will get increase, and the current will also increase. When supply voltage decrease, the voltage across the resistance will get decrease, and the current will also decrease. This relationship can be represented using I versus V graph. From this graph, for example, when the voltage is equal to 1 V, the current is equal to 1 ampere. When the voltage is 2 volt, the current is equal to 2 ampere. When the voltage is 3 volt, The current is 3 ampere. The slope line in the graph is the line to tell the relationship between the voltage and current, and we may use it to predict the current with any voltage applied across the resistor. For example, if the voltage is 2.5 volt, through the graph, we may do a prediction, the current is 2.5 ampere. The slope line in the graph has provided an important information. It is resistance of the resistor. The resistance is the voltage, divided by the current flow across the resistor. It is 2.5 volt, divided by 2.5 ampere, and it is equal to 1 ohm. Or, you may try to use other value, to calculate the resistance. For example, 3 volt, divided by 3 ampere, 2 volt, divided by 2 ampere, and 1 volt, divided by 1 ampere, all this, are equal to value 1 ohm. Please bear in mind that, the Ohm's law is with conditions. The condition is, temperature, and the other's physical condition, are constant. Constant is meant to, remain unchanged and temperature, need to be remained unchanged and, because, temperature is the factor that will affect the resistance of the conductor. The other's physical condition, is referring to, its length, and cross-section area. These are the factors, that affect the resistance. Ohm's law, can be represented, using the equation, or formula. It is, V, equal to, I time R. Please remember, this equation is with condition. And with the condition, the resistance value of the resistor, is a fixed value. Since R remain constant, whenever the voltage across the R increase, it will cause the increment of the current. This relationship is called, directly proportional. With the Ohm's law equation, the following problem, can be solved. To determine voltage, V, if the current, and resistance are given, we may use formula V, equal to, I time R. For example, if the current across the resistor is 5 ampere, and, the resistance of the resistor is, 2 ohm. Calculate the voltage across the resistor. To calculate the voltage across the resistor, we use formula V, equal to IR. It is, 5 ampere, time 2 ohm, and, it is equal to, 10 volt. The second problem, determine I, if the voltage, and resistance, are given. Please take note of the equation, the equal mark. This equal mark, indicates that the component at the left-hand side, is equal to the component, at the right-hand side. It meant that, when I do an arithmetic operation, for example, plus, minus, multiplication, or division, at the left-hand side, the same operation, must apply to the component, at the right-hand side. For example, when the component at the right-hand side, divided by R. At the same time, the component at the left-hand side, must also divided by R. Now, let's focus the right-hand side. When R, divided by R, it is equal to 1. Because, a number divided by itself, is always equal to 1. For example, 5 divided by 5, is 1. Hence, we may eliminate the R at denominator, and numerator. At the right-hand side component of the equation, the final equation, become I, equal to V, divided by R. Let's go back to the Ohm's law equation again. From the rule of mathematic, this is the mathematic rule of the algebra. According to the rule, if you want to determine the I, in the equation, we transfer the I multiplier, R, to be the denominator of opposite side component, V. We get I, equal to, the V, divided by R. Now, we know that, current is equal to voltage, divided by resistance. Let's proceed to an example of the problem. This is the example of the question. If the voltage across the resistor, with resistance of 2 ohm, is 10 volt. Calculate the current in the circuit. We may use the formula, I equal to, the V, divided by R. It is equal to 10 volt, divided by 2 ohm. The current is, 5 ampere. The third problem is, determine R, if the voltage and current are given. If you want to determine R in the equation, transfer its multiplier to be the denominator at the opposite side component. We get R equal to the V divided by I. From this, we know that the resistance of a load is equal to the voltage across the load divided by the current. Let's proceed to an example of the problem. If the voltage across the A resistor is 6 volt, and the current flow through the resistor is 2 ampere. For the solution, we may use the formula, R equal to V divided by I. R equal to 6 volt divided by 2 ampere. It is 3 ohm.